5.4. Factor and solve polynomial functions. For example 1, we're asked to factor the polynomial completely. So remember, we're always looking for a greatest common factor, and then depending on the number of terms, we're going to approach it differently. So if there's 4 terms, we'll look for factor by grouping. If there's 3 terms, we have that kind of general factoring where you're looking for what multiplies at the end and adds to the middle term. If there's only 2 terms, we look for difference of squares. So for A, I notice that all of my terms have y. So first I will factor out a y. Then we have y squared minus 4y minus 12. And now we have 3 terms. So because my leading coefficient is 1, I have 1y squared. I don't have a 2 or a 3 or anything there. I can look at what multiplies to make negative 12 and adds to make negative 4. And that would be y minus 6 times y plus 2. And don't forget to leave the y in front of it. On the next one, all of my terms have an x, and they're also divisible by 3. So first we'll factor out 3x. We're left with x squared plus 10x plus 25. And then I know on this one, 5 times 5 makes 25. 5 plus 5 is 10. So I have a perfect square. And so I want to factor this as x plus 5 quantity squared. On the third one, there's only 2 terms, so I'm hoping to be able to do difference of squares, but I also need to see if there's any common factor, because right now 5 and 80 and nothing's really going to work. So I can factor out a 5 and an x cubed, and we're left with x squared minus 80 divided by 5 is 16. So now we do have an x squared, and 16 is 4 squared. So I will write 5x cubed times x plus 4, x minus 4. Oops, minus. So we have 2 new factoring patterns, sum of cubes and difference of cubes. So there are a lot of different ways to factor these. I'm just going to show you one way. Ms. Hasbrook has a really cool way that she can show you as well. But what I do is I first look at how I have a cubed and b cubed. And so my first binomial is going to be a plus b. And then there's always going to be a trinomial. So for the trinomial, I use this pattern called SOPs. And the first S stands for square. So I'm going to take the a and square it. And then the next is O for opposite. And the opposite of a plus is a minus. The next one is product. I think I'm going to move down here now because I'm running out of space. So product of A and B, which is just AB. And next is always a plus sign. And then the last one is a square. And so now I take B and I square it. So I did square, opposite, product, plus square. So SOPPS. We'll do it on the next one as well. Square, opposite. Let's maybe draw some arrows in. And again, if you don't like this factoring thing, if this doesn't work for you, you can always Google how to factor sum of cubes or difference of cubes. It'll give you other tips and tricks for this. So the next one, because I have a cubed minus b cubed, I start out with a minus b. So you can see that initial binomial is always the same sign. And then again, I'm going to do my SOPs pattern. So I'm going to write it out and kind of go through it with you guys. So the first S is square. So I take the a and I square it. My next term is the opposite in sign. So if I have a minus, now it's a plus. The next term P, that's going to be a product. So a times b is ab. And then this is a plus sign. And then square again. And now this time I'm looking at the b and I square it, and that's b squared. All right. Mothership, othership is a popular one. So you could look that up. So for example 2, we're asked to factor completely again. There's only 2 terms. So I'm always looking for difference of squares, or now I could look for sum or difference of cubes. So from this first one, I'm thinking about how 27 is 3 to the 3rd power. So this is really 3. I don't know why it's not writing. Now it's writing. So this is really 3x cubed. And then the 125 is 5 cubed. So I can see I've got a sum of cubes. So my first binomial is 3x plus 5. And then I'm going to do that SOPs pattern again. So first I'm going to take the 3x and square it. So that makes a 9x squared. And then I have O for opposite. So if this is a plus, now I write a minus. My next term is going to be the product. Product of 3x and 5 means I multiply 3x and 5. That's 15x. The next P is a plus, always. And then the last S is a square again, and this time I'm squaring the 5. For B, two terms again, I want to look at what I can factor out, greatest common factor. It looks like I could factor out a negative. I never like my leading coefficient to be negative. They're both even, so I can factor out a 2, and my lowest power of x is squared. So now I have x cubed, and this will now be minus 125. So it looks like I have another difference of cubes. Remember, 125 is 5 cubed. So I need to keep that negative 2x squared. And then my first term would be x minus 5. And my second term, remember our SOPs pattern again, I'm going to take the x and square it. And then O is opposite. If this is a minus, now I write a plus sign. Product of 5 and x is 5x. And then the next one's always plus, and then the square of 5 is 25. Oops. So for example 3, I am factoring completely, and there are 1, 2, 3, 4 terms. So definitely going to be factoring by grouping. Factoring by grouping, I could still, I guess, do a greatest common factor, but I don't have one on this one. So I am going to look at what I can factor out of the first two and out of the second two. So out of the first two, I could factor out, I'm thinking 3, but really I could factor out a 9. We always want to factor out as much as possible. And an x squared. So 9x squared. And that would leave me with 3x plus 5. And then the second two are both negative, so I'm going to factor out a negative 1. And then we have 3x plus 5. So now, remember, I take these, the 9x squared and the minus 1. That's going to be one binomial. The other one is 3x plus 5. It will not work if we don't have matching sets of parentheses. These two have to be the same. And then I noticed that 9x squared is really, scratch work over here, 3x quantity squared minus 1 squared. So I can keep factoring. I have difference of squares now. So 3x plus 1 times 3x minus 1 times 3x plus 5. So now we factored it completely. So we're always looking, even when we think we're done factoring, once you're down to where you've got a bunch of binomials, I would still look for difference of squares or cubes or sum of cubes. So we always want to see, can we keep factoring? So on 4, we are still factoring completely. So I'm always looking for greatest common factor, then I'm looking at the number of terms. In A, both are divisible by 10. So I'm going to factor out a 10. And then if I have x to the fourth minus 1, remember that's x squared is squared minus 1 is squared. So I have difference of squares. So x squared minus 1 times x squared plus 1. But then this x squared minus 1 is another difference of squares. So x is squared and 1 is still 1 squared. So I'll have an x minus 1 times x plus 1 times x squared plus 1. So this is the kind of factoring we're looking at now, where you think you're done, but you just have to keep going. It's getting a lot more complicated, higher powers. Let's see, in B, 3, 54, 51, so I can factor out a 3 from everything, and my lowest power of x is x squared, so I can factor out an x squared. So we're left with x to the 10th power plus, let's see, what is 54 divided by 3? Scratch work. So it looks like 18. So x squared plus 18, x to the 5th now, plus, and 51 looks like one less factor of, or one less multiple of 3. So this should be a 17. And now I know I can keep factoring because my first term, my x to the 10th power, 10th power is twice as big as 5th power. So I know I can keep factoring, and I know both of them will be x to the 5th. Because x to the 5th times another x to the 5th, remember we would be adding those exponents. 5 plus 5 is 10, and because I'm writing this with x to the 5th, that's going to end up being my middle term. So now I just need to see what multiplies to make 17 and adds to make 18. So that would be 17 and 1, and I'm done factoring here. So for 5, I'm trying to solve. So even though we're solving now and we have higher powers of x and the factoring is more complicated, we still need to get everything on one side. We still need to have it equal to 0 so that we can factor and do zero product property. So I'm going to subtract 12x cubed and add 16x on both sides. I almost forgot that x. So on the right I have 0. On the left I have 2x to the 5th minus 12x cubed plus 16x. I'm always wanting to keep, this looks kind of messy, I'm always wanting to keep my highest power of x positive. It just makes the factoring easier. So now I could factor out x from all of them and 2. So now I have x to the 4th minus, let's see, this is 6x squared plus 8. And my equal signs are not lining up very well. Let's see, 8 would be 4 times 2. And if they're both negative, it'll multiply to make a positive 8, but add to make a negative 6. So x squared, remember this one, the 4 is twice as big as the 2. And then this middle term is going to be what they both have for the x power. So we said minus 4 minus 2. And then it turns out x squared minus 4, because I have two squares with a minus sign, I can keep factoring that. So I'll have 2x times x minus 2 times the quantity x plus 2 times the quantity x squared minus 2 equals 0. So now I'm all ready to do zero product property. So remember this one, my goodness, I have 1, 2, 3, 4 parts. I'm going to have 4 equations, either 2x equals 0, or x minus 2 equals 0, or x plus 2 equals 0, or x squared minus 2 equals 0. So we cannot just write down answers. We still have to write all those equations. We still need to show our solving steps. I'm adding and subtracting, multiplying and dividing. I'm showing all my work. On the last one, when I add 2, I have x squared equals 2. And to solve, I'll have to take a square root on both sides. So the absolute value of x equals the square root of 2. And so x will equal plus or minus the square root of 2. So we've got this big list of answers. X is 0 or 2, or I think we should just list them. Negative 2, plus or minus 2. And I don't really know, it just even seems weird to write the word or in between them all. Like my grammar is really bad, but that's really what we mean, right? X is 0 or 2 or negative 2 or plus or minus 2. All right, this is it for our notes. We're just looking at lots of factoring and solving still. We're continuing the skills that we learned in Chapter 4.